Okay, so we are on section 7.4, compound interest. The first thing we're going to do is kind of define that compound interest. When interest is computed on the principal and any previously earned interest. It is called compound interest. Here's the difference in simple and compound interest. When we've been calculating simple interest all this time, what you're doing is you're going, okay, I have an initial deposit of say $1,000, and in simple interest, we pay 10%. They're going to give me 10% simple interest on it. But that interest that's calculated over those 4 years is just with that initial $1,000 principal. So every year they're just going, okay, first year I pay you $100, second year I pay you another $100, third year I pay you another $100. With compound, we start off with $1,000. Over the year, we earn $100. That's the 10%. And when we start the second year, then we now got $1,100, and we take 10% of the $1,100, not just the 1,000. So then I earn $110 by the end of the second year versus the 100. Then I add that to start the third year. They change the principal when we're dealing with compound interest. They add the interest that you've earned into the principal to calculate the new amount that account earns, is the difference in compound interest. Now, we can find compound interest, which we're going to do in example 1, by using simple interest. The problem is, generally when we deal with compound interest, it's years and years, and you don't want to do 20 years worth of simple interest. So there is a formula that one just puts the values in. But in example 1, we're actually going to do it by simple interest, okay? So example 1 says, for an investment of $100,000 at 6% interest for 4 years, find A, the simple interest, and B, the compound interest if interest is calculated once per year. Okay, so let's start off with A, the simple interest. So we have two formulas that we talked about with simple interest. I equals PRT, and then A equals P plus I, right? Okay. Well, of course, we're finding the simple interest, so that's I equals P RT, which means I need a principal, I need a rate, and the time here is going to be, what's my time here? It's actually 4 years to start with because we're doing simple interest, right? What's my principal?
100 grand.
100 grand, good. And that rate as a decimal is?
0.06.
Yes, ma'am. Thank you. So we're going to put that into our formula. So I have I equals 100,000 times 0.06 times T, which is 4. Okay. When I put that in my calculator, I should have, and you can put that in your multi-view, your scientific calculator, whichever you need to. I've got 100,000 times 0.06. Did I put 100,000? Yeah. Times 0.06 times 4. And you see right over there in the corner, it gives me 24,000, correct? Okay. So I get $24,000 in simple interest. That's what we would earn. Okay. B says we want the compound interest if interest is calculated once per year. Well, here's how we take care of that. We find the simple interest after 1 year. We add that back to the principal. We find the simple interest on that in year 2. We add that back to the principal, and we keep adding and finding interest. So let's talk about the first year. First year is easy to calculate. Okay, I know I have I equals PRT. Well, what's my principal? I start off with 100,000, right? I have a rate of 0.06. And T this time, we're only doing it for 1 year. We're looking at what that would pay in 1 year. So my T is 1. So if I put in 100,000 times 0.06 times 1, which you don't have to put that, how much interest does that account earn the first year?
6,000.
Yes, $6,000. Good. Okay. So what's the amount in the account at the end of the first year? What's that amount?
106,000.
Good, $106,000. Guys, that's your new principal for the second year. Okay? That's what compound interest does. It adds your interest that you earned back to your original principal. Calculates new money based on the new principal. So, second year, I now have I equals, well, my principal now is 106,000 times 0.06. This is only for 1 year, okay? I'm going to say 106,000 times 0.06 times the 1, of course. What does that give me? Good. So that second year, I get $6,360. Okay? That's the second year. So amount at end of second year. We'll shorten that a little bit. Okay. Well, I started the second year with 106,000. Now I made $6,360 in interest. So at the end of that second year, how much money's in my account? 112,360. Okay. That's my new principal for the third year. So going into the third year, I have I equals 112,360, right? Times 0.06 times 1 equals how much do we make that third year? Good. $6,741.60. Good. So, I'm not wanting to write that A. Amount at end of third year. Okay. So I started the third year at 112,360 and I earned 6,741.60. So at the end of the third year, I now have good $119,101.60. Very good. Okay. Now I need the yes.
Sorry, I didn't get a chance to. Let me tell you that she did running.
Oh, okay. That's fine. Fourth year, we're gonna start with 119, 101.60 times, of course, my 0.06 times 1. Okay, so times 0.06 times my 1, which doesn't do anything. How much interest do I earn that fourth year? And 10 cents. Yeah, we're going to round that one up because we have 0.096. Guys, we need to round to the nearest cent. There's a 6 behind that 9, so that 9 needs to round up to a 10. So that's going to give me 7146.10. Okay? Now, the question asks us to find the compound interest if it's calculated once per year. Well, here's the deal, guys. You've got to add up all those interests for the 4 years, right? We found in A that if we just did it with normal standard simple interest, we made $24,000 in interest over 4 years. Let's look if we're doing the compound. Let's add all those together. Okay, I need you to I can't get back over there because it's my other thing's in the way. All right. Oh, guys, that's so annoying. This is why I don't use this. Okay, you're going to get a weird color here, okay? We need to add up all of our interest things here. Okay? Oh, hold on. Not that one. Okay? So, my interest is going to be the compound interest. Ooh, I need to change that size. Okay, the compound interest. There we go. Is going to equal the 6,000 plus the 6,360 plus the $6,741.60 plus the $7,146.10. When I add all those together, which y'all probably already did, what did we get? while you were waiting on me to change colors. Okay,
You're asking how much interest specifically was accumulated over the 4 years.
yes,
I got $26,248.46.
close. I'm getting $26,247.70. Let me make sure I have all the other numbers right. 460, 630, 66,000, yeah. You made a little extra money there, Autumn. Yeah, I'm getting $26,247.70. Okay, whereas before with the simple interest, we only made $24,000 over those 4 years. If that interest had been compounded, it would have been $26,000, and that's $2,247.70 difference. I mean, it's a nearly $2,300 difference. Makes a difference, guys, on the compound interest. Okay. All right, let's look at, we got a couple of math notes that we need to write on here. Okay, the first one being a savings account. So vocabulary item, a savings account where the principal and interest can't be withdrawn for some fixed period of time without penalty is called a certificate of deposit. Okay. And then our other math note, you may need that for a vocabulary question. You know, lots of times they do like to throw those in there. The second math note, you do need to work your homework problems here. When interest is compounded, yearly, and they'll use the word yearly, n will equal 1. If it's compounded semi-annually, if they use that word, that means n will equal 2. And then quarterly, that means n will equal 4. And daily, n will equal 365. It will not equal that 360 of the banker's rule. It will be 365. Okay? Now, we don't necessarily want to have to, when we find compound interest, we don't want to have to do what we did up here in example 1, where instead of doing it 4 times over for 4 years, then I actually do it like if it's compounded over 20 years. Okay? Lots of times, guys, when we invest certain amounts of money, and we put the money in there to stay and grow in an account, it's over 20, 30 years. I mean, you don't want to be, somebody's not hand doing that each year. Okay? So we have our compound interest formula. it is going to be A equals P times 1 plus R over N all to the NT. Guys, this is why I told you you either needed your multi-view today or you need to pull up Desmos Scientific Calculator and use that one, okay? I'll use the Desmos Scientific Calculator today just so I can switch back and forth very easily. Since I'm not using an iPad, I can't switch to the camera and then slide the calculator under there, which sometimes that gives y'all, makes you dizzy, okay? P, of course, is my, well, what is A? A is the same thing as it was before.
It's the future value.
Good. It is the future value. That's the total in the account at the end of the period, the end of the years, however many that is. P, of course, is my principal. Okay. R is going to be my rate. T is time. And what does N stand for?
How often the interest is compounded?
Good. That T is in years, just like before, and N is the number of times per year. The interest is compounded. Okay? Okay, so let's look at example 2. Example 2 says, we want to find the interest on $600 compounded semi-annually at 4.5% for 6 years. Okay, so we start with our formula and then we list what we have. We have A equals P times 1 plus R over N all to the NT. Okay, so guys, you do need to notice that in that compound interest formula, it's giving me A, right? A is the future value. That's the total amount at the end. They're not asking me for the total amount in the end. They're asking me for the interest. So we're going to have to do something else to this when we get our answer. Okay, just be careful. Okay, so it says it is find the interest on $600. So my principal is $600, right? Compounded semi-annually. That semi-annually tells me what my N is. What's my N going to be? 2. We wrote that down up at the top, that if we use the word semi-annually, that does mean 2. Okay. At 4.5%, so R, express that 4.5% as a decimal, is what? Good. 0.045. Okay, and time is 6. Okay. So let's start plugging them in. I've got A equals 600 times 1 plus R is 0.045 over N, which is 2. All times NT, so that's 2 times 6. Okay, So what I would do is either go to your multi-view, or I'm going to go to the Desmos calculator today. And I'm going to delete all that. And let's see if we can build that. I've got 600. I have parentheses 1 plus, then I'm doing 0.045 divided by, and you see how nicely Desmos will go ahead and stack those fractions for me. 2, and your multi-view will stack them also, but if you don't have a multi-view, it will not stack it as easily. It won't stack, okay? So I've got 600 times 1 plus 0.045 over 2. Now I need to raise it to the 2 times 6 power. Guys, right by the a squared, you see an a to the b. If you'll push that a to the b, it'll throw the cursor up to an exponent. And you should be able to do 2 parentheses 6. You can type it in just like that. You don't have to say times. And it does give you the amount that you have right there. You can see your answer down here in the right-hand corner. Right here. So the future value at the end of those, 6 years, you have a total of $783.63 in the account. Okay?
There is also a scientific calculator app on your iPhone.
Yes.
It's the base calculator app, but you have to click a button.
Yes, you can click the calculator icon in the calculator and you can switch over to a scientific calculator. Will it stack the fraction, Autumn?
You have to use a nested parentheses.
The parentheses.
Yeah, I did 600 times parentheses 1 plus parentheses 0.0.5 divided by 2 parentheses
Mm-hmm.
to the ball.
Yeah. And
so it's a little jank, but it works.
Yeah. And if you don't have a multi-view and you have the one that's right below that, you can do the same thing in there and do the nest. If you know how to nest the parentheses, you're fine with the calculator that you have. It's just Desmos, and the multi-view will show it to you exactly like you want to type it in with the nest, with them stacked. We don't call that nested, we call it stacked, with the stacked fraction, so you can see what it is. But if you're okay with, and some of you are, because you've run a calculator enough in high school that you know how to nest that way, and you can just nest on the calculator that you have. Nest your parentheses. Yeah.
Is it best to just type it in
Doesn't matter. It's what is easiest for you. You can actually go in there and do the 1 plus the 0.045 divided by 2. See what you get for that. Raise that to the 12th power. Then multiply that by the 600. As long as you know what's going on, you're fine. Because you're going to get the same answer. It's pretty much how you do it is based on your personal calculator skills. Okay? That does give me $783.63. Is that my answer? No. Guys, that's the future value. That's the value at the end. We learned back on our simple interest days that the future value equals the principal plus the interest. We are looking for that I for that interest. Guys, that means that I equals A minus P. Okay, so you need to kind of be aware of this. This is important. We're just going to write it like that. I equals A minus P. That means my interest is going to equal 783.63 minus, my principal was originally $600. So the interest I made was $183.63. Guys, that's not a lot for 6 years worth of investment on $600. You probably could have spent that $600 in a way that would have made you more than $183 over the 6 years. Take, for instance, I purchased the iPad Pro probably 5, 6 years ago. I have upgraded over the time, but 5, 6 years ago when I first started teaching at the college, out of my own pocket, because I knew I could teach better that way. Price around then, or well, the last time I bought it was like $1,200. There's $600 right there, and I use it to work with, and I make way more than $183.63 over 6 years. It depends on how you invest that $600. This one wasn't a good investment to put your 600 in there. Okay. Example 3. Let's try another one. We're going to do the same thing. We have find the interest on $50,000 compounded weekly at 7% for 20 years. Okay? Assume they're nice to you. Assume a 52-week year. Okay? All right, I write down my formula. Guys, you will be given the formula for your test, so don't worry about memorizing it. 1 plus r over n, all to the nt. Then you start labeling what everything is. Put a number to a letter, okay? Find the interest on $50,000. There's my principal right there. P equals 50,000. Compounded weekly, well, that's my n because it says assume a 52-week year. So weekly is going to be 52 set as my n because that's the number of times a year that I compound it. Every week, there's 52 weeks in a year. Let's see, what else do I have? 7%, that's my R. By now, we've done enough rates that I know that I have to express that as a decimal, 0.07. And time T is 20 years. Okay, so this is a pretty lengthy investment, and it's a pretty hefty one. We're putting $50,000 in to start with, and we're letting it sit. Okay, we're going to see how much interest we make on that. So I've got A equals, my principal is 50,000 times 1 plus my rate is 0.07 all over n, which is 52, all to the 52 times 20 power. Okay? So I'm going to go over here and I'm going to use my Desmos calculator. And I'm pretty sure there's a different way to clear that. I'm going to put in 50,000. Then parentheses 1 plus 0.07 divided by 52. I need to use the arrow over to get back out of there to do my parentheses. Then I'm going to do my a to the b to give my exponent, and I've got 52 parentheses 20. And that means at the end of those 20 years in that account, I will have $202,569.20. Okay, that is correct.
Enough to buy like a third of a house.
Yes, that's about right. A third of a house after 20 years. Provided the house hasn't gone up in price at that time. We do get 202,569.20. Okay. Now, once again, that's the amount in the account after the 20 years. That's not what this asks me. It says find the interest that this account paid out. So up here, I wrote a new little formula, I equals A minus P. So I'm going to say I equals A minus P. That's going to give me I equals 202,569.20 minus 5123, 50,000. And that leaves me with this account that I put that 50,000 in. It earned me $152,000, 569.20 over those 20 years. Now, if you have just $50,000 that you can go, I don't need you for the next 20 years, then this isn't bad. You made approximately $150,000 in 20 years and didn't do anything except loan your money out to whatever institution was paying you this much interest. Okay, this isn't a savings account. Savings accounts do not pay anywhere near that amount of interest. Okay, at the bank, they do not.
Are weekly compounds even very common? I've only ever heard of annual.
They can be. It depends on what you're buying in the financial institution. So it's not going to be a bank. It's going to be something else that sells possibly stocks and bonds and deals with it. If you meet with a financial advisor, they know of these places to put that. But it usually is like there's a minimum amount that you have to deposit. Like probably the minimum on this account was you had to deposit at minimum $50,000 to even start the account because that institution is loaning out millions of dollars to other entities at a much higher interest rate.
Yeah, I was speaking with somebody a couple of months ago at JP Morgan,
Mm-hmm.
and there were some like executive brokerage account that they needed a minimum of 10 grand
Yes.
to open for.
Yes. Yeah. And there are some that it's even more than that. And you're going, look, I'm still in college. I can't give you. I don't have. If I had $10,000, I probably wouldn't need to come here. That kind of thing. Okay, let's talk about what an annuity is. And some of you are familiar with annuities. An annuity is a savings investment plan, in which the investor makes a regular fixed payment into a compound interest account. Where the interest rate doesn't change during the term of the investment. Okay? An annuity is a savings investment plan in which the investor makes a regular fixed payment into a compound interest account where the interest rate doesn't change during the term of the investment. Okay? These are like the ones that my children had to go to college. They were called Schwab accounts. We called them Schwab accounts because they came from Charles Schwab Institute. But what they are is their IRA accounts, okay, where their grandfather had set them up with when they were born. He deposited a certain amount of money into an account every year for 18 years. And then by the end of the 18 years, when they graduated high school, they had a certain amount that then they could go to college on. That's an annuity. That one also has other restrictions on it because it's an IRA that money cannot be taken out except for college purposes, for school purposes. If the money is taken out and used for other purposes, you pay what we call a penalty on it, plus you then pay taxes on it at the end of the year on income taxes. So it's set up specifically just as an education account. Okay, but the way it works was, okay, there was an initial deposit made, then an interest is earned on that initial deposit. Then at the end of that year, when you started the second year, the same amount was deposited in there. So if the first year there was 1,000, the second year another 1,000 would be put in, plus the amount of interest that was earned from the first year. And then you find the extra interest based on that new principal that included both year deposits plus the first year interest. Okay? So it's kind of like a souped up compound interest account is what it is. Okay? Let's look at the formula for finding the future value of an annuity. Okay? We have, now this one gets a little messy, guys. A equals, we have this capital R, and we're going to multiply that times 1 plus our normal lowercase r over n, all to the nt minus 1. And that's all going to be over, that was a big 1, wasn't it? There we go. R over n. Okay, there's only one new letter that we have here, and that's that capital R. And that capital R is going to stand for the reoccurring payment. Okay? This is the reoccurring payment. And you'll see what I'm talking about when we do the example. Okay? So let's look at example 4. Girls, do y'all have a question? Do we have a question? Okay. Example 4. We have find, A says, find the future value of an annuity when the payment is $275 quarterly. The interest is 6.5% compounded quarterly. And the term is 6 years. So we just ramped it up quite a bit from our simple interest formula that we do, right? Okay, part B says we want to find the interest earned. Okay, so they start out nice to us because they ask us to find the future value, and our formula is in terms of the future value. Okay, so we're going to do A first. We have A equals R times 1 plus R over N to the NT minus 1 all over R over N. Okay, so we need to label the things that we know. First off, can you tell me what capital R is?
275.
275, good. Then let's talk about my lowercase r. What's my interest rate?
0.065.
Good, 0.065. Then I've got an E, not an E, an N, I'm sorry. I've got an N. How many times per year is that compounded?
4.
4, because it says quarterly. Okay, and the term T is 6 years. Good. That takes care of everything I needed. I needed a capital R, a lowercase r, an N, and a T. So now I'm ready to plug those in and then try to build that in the calculator. So I've got 275. When you go to use your calculator, do not use a bracket. Okay? Brackets and calculators are used for coding. Okay, it codes in the calculator just like it did in that 84 plus CE that you used. Those brackets code. That's what they're used for. Most of your 84 pluses had Python graphing built in. The little Desmos one is not going to want you to use a bracket either. Use double parentheses. So I'll write it with double parentheses, okay? So we have parentheses, then we have 1 plus 0.065 all over 4. Okay, to the 4 times 6 minus 1. And then I'm going to close those parentheses. Then I'm going to divide by 0.065 all over 4. Okay, so let me go over here and see if I can get that built. Okay, so I'm going to go back. And I'm going to say 275. I've got a parentheses, and then I've got another parentheses, 1 plus 0.065, close parentheses, my little rooftop, 4 parentheses 6. Then I'm going to come down and say minus 1, close parentheses, and then I'm going to divide all of that. Notice it went ahead and it threw it as a stacked fraction. I'm going to say 0.065 divided by 4. Okay, so I think I'm good to go. And it tells me at the end, that is not right. Something went bad. What did I type wrong, guys? Oh, I forgot to divide this one by 4. The 0.065, it needs to be divided by 4. Look at what we wrote. I was like, we should not have that much money. Yeah, we wish. We would totally invest there if we did. Okay. Now, that looks better. At the end of these 6 years, we will have $7,993.75 in our account. That takes care of part A. Okay? We will have $7,993.75 at the end of the 6 years. Okay, so you're thinking, well, that's not too bad. I started with 275, but let's think about it, guys. B says find the interest earned. Okay, well, we know my interest is actually going to be A minus P. And you're going, yeah, that's still good. Because you're thinking that P is 275. P's not 275, guys. You paid in more than $275. What does this say? It says when the payment is $275 quarterly, so you're putting $275 in there 4 times a year for how many years? 6 years. Okay, guys? So, here's what we know. When we're talking about the principal that we deposited here, okay? I'm depositing $275 4 times a year. Okay. Well, how much is that in 1 year?
Oh, sorry.
In 1 year, yeah, 275 times 4 gives me $1,100 for the year. Okay. That's $1,100 for the year. Now, how much is that for all 6 years? I did that for 6 years. Yeah. For 6 years, the total deposits,
Yeah, it's not great.
yeah, it's not great, are $6,600. Because guys, that's what that tells me. I paid in $6,600, and at the end of 6 years, I've only got $7,993. I didn't get much in interest there. Okay, so I say that my I equals $7,993.75 minus the $6,600. Which gives me only $1,393.75 in interest for those 6 years. That's not great, guys. Not when you paid in over $6,000 yourself. I mean, it's better than nothing, but I'm thinking we could shop around and find something better. I really think you should. Okay? All right, example 5. Let's do another one like this. Let's do another annuity. Then we'll talk about effective rate. We have find the monthly payment needed to save needed to save a $6,000 down payment for a car in an annuity. So at least they told us what we're working with. That pays 5.5% interest compounded monthly over 2 years. Okay, so this one's a little different. It's not asking me for my future value. It wants the monthly payment. Which one of those letters in our annuity formula goes with the monthly payment? Which one do you think, guys? Okay, this one's a little bit tougher. Okay, it says find the monthly payment needed to save a $6,000 down payment. So here's the deal. $6,000 is actually what you want at the end of the time. So here's what you're doing. You're investing some money into an account. They're going to pay into an annuity. And they're gonna pay you some interest, and you can keep making payments in there every month. And at the end, you want it to have $6,000 in it, because you got to take that over to the car lot and use that as a down payment. The $6,000 is a down payment. Okay. So that's what they're asking. So A is actually the $6,000. Okay. A is my $6,000. Says monthly payment, and the interest is going to be compounded monthly. So that means N is what? 12. What's R? Baby R. Yep. I should say lowercase r, not baby r. Sorry. T is 2, right? Because it's 2 years. So the only thing I'm missing is my big R. The big R is that monthly payment that you're going to be making. So we want to solve for R. So that's going to take a little work with all that messes going on there, isn't it? Yeah. Okay, but we can do it. We're going to plug in what we know. We know A 6,000. We need R. We don't have that. And that's going to be 1 plus 0.055 over N, which is 12, all to the 12 times 2, minus 1, and all of that is over R over N, which is 0.055 all over 12. Well, guys, here's the first thing I'm going to do. I'm going to take that 0.055 over 12, and I'm going to find out what that is. Okay? I don't generally suggest you do things like that, because y'all want to start chopping off decimals, and that's not good. Okay? But you kind of need to on here. Okay? Write some decimals down, because this is... We could do it without... How do we get rid of the 0.055 over 12 from that denominator? Multiply. So we don't actually have to divide that out first. We can say 6,000. This is really 6,000 times 0.055 all over 12. That's going to make this go away, and that's going to equal R times 1 plus 0.055 over 12. All to the, well, that makes 24, right? Minus 1 power. Okay. You tell me this. How do I get R by itself? What's happening to R and the big uglies over there? They're being multiplied, because I got R and I got a big set of parentheses. So we can actually divide both sides by that big chunk that's sitting by R. Okay? So I'm going to divide both sides by 1 plus 0.055 divided by 12 to the 24th minus 1. That looks awful, doesn't it? Okay? It's not that bad, though. You're going to put it all in the calculator at one time. And life's going to be grand. That's 12. I can make it 12. All to the 24th minus 1. Okay. So here's what I have. I'm going to write it nice where you can kind of see it. I'm saying 6,000 times 0.055 over 12 all over 1 plus 0.055 divided by 12 to the 24th power minus 1. If you can get all that in your calculator at one time, can you do it? Yeah, you can do it. You don't want to do it? Let me write it down over here, and I'll try to put it in the calculator. Let me write it on the back of it. Oh, this marker needs to be thrown away. It's boo. 5. Has anybody got an answer for me yet?
No.
Did I forget something? It is quite possible. Because I was worried about the ink stringing instead of writing the numbers down right. Okay. All right. Let me go over here. I'm going to try it now. Okay. You got an overflow error? Okay, so I've got 6,000 times 0.055 divided by 12. Okay. And then all of that divided by, yep, we got that in there. I'm going to say parentheses, then another parentheses, 1 plus 0.055 divided by 12. And then I'm going to go outside, and I'm going to close that parentheses, and then I'm going to use my little exponent button and say 24, and then I'm going to go down, and I'm going to say minus 1. And then I can close that parentheses. Okay, can y'all see it? I don't know if I can make it. All right, that's what I have in there. Is that what I'm supposed to have? I can make it go up. I'm sorry, girls in the back. There we go. Let's see what it's telling me the answer is. It probably said overflow area. Is that what the triangle's saying? You need something before the superscript symbol. Oh. What does he mean I need some? Oh, that's like, oh. I somehow gave myself a, now that, nope. You should get, what number is this? Oh wait, where am I at? Let's see, 237.07. Yes. Yeah, that's what we're supposed to get. I put it in the calculator wrong somehow. Where is he telling me? What, why did he get upset here? He doesn't like me. I think that's it. What does he mean? I know what a superscript is. That's here. Okay, let's see. No, that one, that shouldn't matter. I don't want to retype the whole, I am not retyping the whole thing. I already did it like 3 times and I got it right the first time we did it. I'm not redoing that thing. That's annoying though. I can just Photoshop the answer over there. Okay. Well, I'm gonna redo the whole thing. Let's. Okay. It's still upset. There's like something. It's like this is as a superscript. Like when I deleted a while ago, that's what happened. When I deleted a while ago, I thought I had it all deleted, and he's sitting up at the top like that whole chunk was being used as an exponent is what it was. Okay, see, now it went away. Okay, hold on, I'm going to type it in there. I'm going to get it because now y'all have gone, oh well, you should just really retype it. Just Photoshop. No, I'm not going to just Photoshop it. Look at y'all. Y'all knew that'd get me going. And then I'd go over here. Y'all know how to manipulate the situation. I'll give you that. 1 plus 0.055 divided by 12. Parenthesis, not a parentheses there. Go out. Close parentheses. All to the 24th. Yep. Then minus 1. And close parentheses. Now there, look at you. See there? I told you. I just didn't delete enough on the other one. And if I had looked over in the corner to start with, I would have seen that it was giving me an error when I was typing. Like when I first started off typing, it gave me an error. Sorry. Potential spam. Okay, so we good. We got it stacked. It is 237.07. Let's see what we're actually trying to answer there. That was what you were, that was the monthly payment. We don't have to do anything else. So you're going to have to make, or this person is going to have to make a $237.07, right? Was it 7 cents? Was it 07? 7-cent payment per month. Do that for how long? 2 years to acquire $6,000. So for 2 years, they're going to have to save $237 a month. At the end of 2 years, they'll have $6,000 and they can go try to get the car that they want. That car will be long gone in 2 years. And the newer model will cost way more and they'll need more than $6,000 for down payment. But just saying. Okay, we got to talk about the effective rate. What time is this class over?
5 minutes.
5 minutes? Okay. Let me write the effective rate and then I will post the notes with those on there. Okay. So you can do your homework. The effective rate also known as the annual yield. Is the simple interest rate which would yield the same future value over 1 year as the compound interest rate. Guys, we use the effective rate to measure which one is actually going to pay us more money. So what you'll do is you'll have 2 different scenarios. They'll go, I'll pay you this much interest rate compounded quarterly for this many years. And you'll have a local investment competitor going, well, I'll pay you this interest rate, maybe compounded semi-annually, come over here. And when we use the effective rate formula, it shows us which one will pay the best is what it does. And that's the formula for that. I will work examples 6 and 7 for you and add them onto the end and post the notes. Okay. But it is pretty much 11:30. It's time for you guys to go. Okay. Good job today. We did a lot.